So, myself, Gaurav Doon, and I have my partner in crime, Dan Russotto, also in here. We are from the Intuit Persistent Service team at Intuit. And today we want to talk about how are we leveraging StarRocks for OLAP online analytical processing needs at Intuit. Let's go over the agenda quickly so that you get an idea of what we will be getting into today. First, we're just going to be talking about what is IPS OLAP, what is IPS, and how does OLAP come into play in IPS. What are the different use cases? So today we are going to cover two type of use cases. Both are real time, but they are on the different side of the spectrum. One is for the real time ML model predictions. The other one is for driving real time marketing data attributes. Then we will talk a little bit about why did we choose StarRocks. There were some other technologies that were also out there, and we were using one of them as well. We'll talk about why we decided to go with StarRocks. At that point in time, I will hand it off to Dan, where he will take us into a deep dive into our platform architecture, some of the best practices that we have built along with our platform, and he will wrap it up with the roadmap as to what we have planned for the future. With that, let's get into it. So the first thing is, what is IPS OLAP? As I said, IPS stands for Intuit Persistent Services, where we are a platform team with multiple products around OLTP databases and other data distribution technologies. What do we do? We are basically a team of experts and platform engineers where we build a platform that abstracts away system level nuances from the end customers, and while still maintaining a certain level of operational as well as performance excellence for these processing systems. So the clients, the end clients, the developers, they can just focus on their business use cases, such as identifying trends and patterns in their data, real-time ML model predictions, what if scenarios, forecasting any future outcomes. These use cases that I'm calling out are OLAP specific, but they apply basically to IPS in general as well. Now, as you see in the picture in here, these are the four pillars of what IPS stands for. We manage the infrastructure for our clients, ensuring availability, scalability, disaster recovery, monitoring, all of those things. And we, sorry about that, and we provide them with the platform. Now, what this platform does is it basically allows them just to give their own configurations to be able to set up their data ingestion, as well as a way for them to query that underlying data with guardrails built around it to ensure that one customer cannot bring down the whole cluster. So ensuring that we are taking care of all of the best practices there. Data, where we allow them to define their entities, which we use as a term for our underlying tables in this case, but entities is a very common term, and allow them to have schema evolution. Again, they just define their entities and they can change that schema based on, and we take care of all of the deployments of the schemas and evolution of the schema underneath through our platform itself. Access control is something I already talked about, and data lifecycle is another important thing in today's day and age with all of the compliances that come with different types of data. So that is also very important, and we provide support for that in our platform. Last but not the least, and the most important, is the people. So since we said that we abstract away system level nuances away from the people, from the end users, I should say, that way we provide them with the expertise from our side and built in expertise into the platform as well, so that it's easier for them to adopt a new technology. We have the 24/7 support, and of course we work with the vendor on ensuring that everything is working seamlessly without them having to worry about the system. So that is IPS OLAP, what our team does. Now, let's talk about the use cases that we have been solving at Intuit. These are just two examples that I'm going to talk about. Both are for real time, but on different spectrums. So, the first use case that is powering multiple machine learning models today is the real time model prediction. So, this is a scenario where this ML model gets its features from real time raw clickstream data from our products like QuickBooks Online and TurboTax Online. The model makes a prediction based on the past 30 clicks of in product clicks of the end user. And these are the two type of features that needed to be supported. First one is reactive. Reactive is where this model is powering Intuit Assist, which is our um, AI solution for uh, customer support. And what this reactive model does is it empowers Intuit Assist to know what the customer has gone through so far in terms of the Q&As that they have already gone through, what workflow they are stuck at. So it gives this data to Intuit Assist so that Intuit Assist can have personalized recommendations ready for them. This reduces escalations by a lot and helps the customer get the help as quickly as they need so that it's less escalations and less problems for our end customers. The second one is proactive. So we talked about reactive where a customer goes to Intuit Assist and gets the help that they need. But proactive is more about without even customer going to the Intuit Assist and asking for help. The useful information in terms of tips is provided to them without them even reaching out. And at the same time, this model will also help detect to see if they are stuck in a workflow in our product and will offer them expert help without them having to think about it. So this is like the proactive part of it, and the other one is reactive. Now, this team had a very strict requirement when it came to data ingestion as well as being able to read what the user has been doing in the past X amount of clicks. And their SLA for the whole thing end to end, like getting the data into the system and reading it out, was 4 seconds. The data that is coming in comes in at a very, very high throughput. You're talking about over 100,000 events per second coming in during the peak time. And this is just the ballpark number. Actual number is a lot higher. So in this case, what we were able to solve was we were able to get the write and the read data total latency of around 2 seconds, where the data freshness was done around the lowest flush rate of 1 second that is supported. We are working to reduce it even further for other use cases that might need it to make it a sub-second as well. And the last is the read query latency, where we were able to achieve TP99s of less than 500 milliseconds. So in the end, if you look at it, you add the two together, we were able to achieve the required SLA that they needed for 4 seconds and empower these Gen AI experiences for our end customers. Next one. So the next one that I want to talk about is also a real-time use case, but it's a little bit different. This is not about powering Gen AI experiences, but it's about marketing. So the demand for real-time aggregates is growing constantly in today's world, driven by in-app personalization for the user, recommendations, as well as targeted marketing. So we have two type of use cases when it comes to deriving marketing attributes. The first one we call is a composition use case, where it's a composition use case where, for example, if you think about if you have to determine the total number of employees in QuickBooks Online and QB Payroll on two of our products, it is necessary for us to join events from multiple real-time topics across these two domains. This is just an example that I'm giving for the composition. So basically, you have real-time data coming in from multiple real-time topics across these domains, and you need to be able to join this and get the derived attribute out on time. Stateful is another one where, based on the previous state of a particular attribute, you look into it and you change it accordingly based on the incoming event. So the example of this one is, in order to determine the count of active customers for a QuickBooks Online company, we look at that event, and based on its current and the previous state, the derived attribute, for example, in this case is called QBO active customers, will be either incremented or decremented based on the existing event. So this team had a requirement of SLAs from sub-seconds to minutes. You, again, as I said, it's on the other side of the spectrum where the requirements are not so strict, and the reason for that is the large, very very large amount of historical data that they have to do. And team was unable to use its existing solution, data warehouse solution, for the real-time composition that I talked about. And here are some of the results. So basically, I've categorized it in 4 use cases: small, which is up to like 2 billion historical records; medium, large. And these are for the stateful processing, where they look at these records in a stateful manner, and you can just see the SL improvements, like it's night and day difference. Next one. All right, so those were the use cases. Now I wanted to talk a little bit about why did we choose StarRocks as our data store. We did a very in-depth analysis, but I just wanted to share a quick summary of what were some of the things that stood out to us and were very important to our use cases at Intuit. Multi-table join support and performance, that is absolutely a must-have. We have a lot of use cases which do multi-table joins, and the performance for that was a very critical factor. ANSI SQL support goes a long way because most of the people are very well versed in SQL, and this makes it very, very easy for adoption. Horizontal and vertical scaling, this comes from the operational side of the things, where any distributed system should be able to do both without a hitch. Real-time upsearch support, that is also a game changer. With the primary key tables, to be able to do that makes it easier to support a variety of use cases. Data warehouse capabilities is something Dan will talk about in the roadmap, but we are excited to explore them with external catalogs. And last but not the least, I would like to give a special shout out to Cellar Data, the vendor with whom we have been working on the adoption of StarRocks. They have been excellent so far, and it was very, very important to have this relationship with them, them showcasing their commitment, and that was one of the deciding factors. Some of the alternatives that we had looked into, Druid is something that we were actually running on premises before we moved on to StarRocks. It was a lot more expensive for us. When we talk about cost numbers, it was 40% more expensive for standard traffic and 150% hard more expensive when it comes to peak traffic. It is very limited in what it can do in terms of the capabilities that I've called out above. It was not so good with joins, and it has a very, very complex architecture, which makes it very hard actually to handle operationally. Some of the other ones that we looked into, ClickHouse is another popular player that is out there in the market. But after talking to multiple people in the community, looking at multiple blogs and talking with other teams, multi-table join is something that is not so performant in there, and we have a lot of use cases for that. Upsets are not natively supported. You can do it, but it's not natively supported. So again, it's an overhead that it adds into it. But last one that I want to call out was horizontal scaling. Again, horizontal scaling can be done, but with an operational overhead where you can develop your own solution, but it's not out of the box, which makes it harder for us also. Some of the other ones that we also looked into a little bit was DuckDB, but it runs on a single node. That was a no-no for us operationally, and Pinot, which just doesn't stand up to it in terms of the query performance. All right, before I hand it off to Dan, I just wanted to give like you a quick high-level architecture, and Dan will go in depth about each of these layers, about with the ingestion and the query layer as well that you see. So basically the flow that in terms of the user journey today, the client comes in, they give us their ingestion configuration. Based on the configuration, we have an onboarding service which automatically takes up that configuration and sets up either a real-time Flink pipeline or even a batch pipeline. And yes, we do have both type of use cases at Intuit, where we have chatbot agentic AI use cases where the data comes in incrementally on a batch basis, but they want real-time query performance. So once the ingestion is set up into StarRocks, as you see here, we have said that we are using shared data architecture backed by the AWS Object Storage S3. And once it is set up, then we have our own abstraction query layer, our own guardrail around the cluster itself, which ensures we follow the best practices. And Dan will go into much more detail about this. But basically, the client does not directly interact with the cluster. They interact with our service layer, and it's a very minimum service layer that we have built on top. We're not trying to introduce additional latency. It's a very minute amount when you look at it. We're talking about 10 to 20 milliseconds, and but it allows us to ensure that the cluster will remain in a good state and people are following the best practices. So with that, now I will hand it off to Dan, who will actually take a deep dive into our platform architecture, talk about the best practices, and wrap it up with our roadmap.
All right. Thank you very much, Gaurav, for the introduction. And as he said, I will be diving a little bit deeper into the architecture and the specifics of the platform that's powering the use cases that we've discussed so far. So the first thing that I want to talk about is our ingestion architecture. The first thing that we do when we are setting up a new use case is to set up the real-time ingestion pipeline using Flink. Flink is the best technology to consume real-time events from Kafka. It's a technology that is designed from the beginning for real-time processing, but it is a technology that is complex and not everyone will have the expertise to deal with that technology. So we provision everything for them. When people come to the platform to set up their ingestion, we provision all of the pipelines for them, and we set all of the monitoring. We have dashboards and alerts for all critical use cases so that all production data is flowing well and without any issues. So there are, in addition to the primary ingestion, real-time ingestion that we have for the platform, we also have a few other different specific and ad hoc use cases. The first is backfill. In this scenario, we might need historical data from further back than when we start the ingestion pipeline for the new onboarded use case. And that way, from the very beginning, new use cases can have all of the data that they need for their analytical purposes. The next type of pipeline that we have is replay. This is for ad hoc needs to change the data that we have. So for example, we might imagine that there is some kind of data issue identified with the stream pipeline. We can use data replay to re-ingest the events that need to have some data correction. And primary key tables and StarRocks can handle the upserts so that all the data is replaced and up to date. We might also imagine use cases where new attributes are required from the data stream that aren't presently there. So what we can do in this situation is to add the new attributes to our tables and StarRocks, and then once again, run the replay with the new attributes. And that way, all of the existing data has all of the attributes that are needed, and all of the nulls are replaced with the new attributes that are required for the updated use case. And all of this can be done completely seamlessly with no downtime whatsoever. The way that we power this is by re-ingesting with a batch pipeline as opposed to our regular stream ingestion for the primary use case. And we re-ingest the events that have been stored in S3 in our data lake that contain a backup of the events that were played in real time from the primary ingestion topic. Now, in all of our pipelines, we also provision many features that will be required for operational excellence. So this may include event schema validation. So to make sure that the events are having the exact format that we expect them to have, so that we don't get bad data ingested into the StarRocks database. We also have data transformation, so that if there's any changes that need to be made to the data in between the Kafka topic and the final data store in StarRocks, we can do that for them. And then finally is application level encryption. Different attributes may have different levels of sensitivity, and for extremely sensitive data, we want to make sure that that is completely secure beyond just data storage encryption, but also even at the application level, the data itself, the columns themselves have encryption. The next thing that I want to talk about is our query REST layer. So as Gaurav mentioned, we don't in our platform allow direct access to the database. We have this query REST layer to protect our production use cases. And the query service has many different features that allow this to happen. The first, of course, is authorization. We want to make sure that individual client services, as well as the users that are using those services, are only getting access to the data that they are authorized to have. So we utilize attribute-based access control to make sure that every request is authorized, and making sure that that data is only going to users who have access to it. The next thing that we have is query validation. So as I'm sure many of us know, with StarRocks, data modeling is critical to making sure that queries are performant as well as ingestion. So in this scenario, we have some validations that we put on the query to make sure that data partitioning, data distribution, data sorting, and indexes are all effectively used, so that we don't have a single bad query that is taking up too much of the cluster's resources and causing noisy neighbor problems. The next thing that we have is profiling. StarRocks does have query planning and query profiling features. So we want to expose that to our end users, so that they are able to optimize their queries and meet all of their SLAs. The last thing that I want to talk about in our diagram here is that, again, we want to abstract away the inner workings of StarRocks and those complexities away from our users, so that they can just focus on the business problems. They do know their data, so they will define their entities in GitHub. And then we have build jobs that will take the data definitions that they provide, which is more generic and easy for them to understand, and create the DDLs for the tables and materialized views that are then first deployed onto StarRocks, and then installed into the query service for data serialization and deserialization. Next, I want to talk about other ways that we are protecting our StarRocks clusters. Again, we have the query REST layer as one mechanism to protect our clusters from any bad actors or any operational issues. But we also are using throughput throttling at our API gateway level, so that the number of requests coming to the clusters are not overwhelming it. And we also are using many of the StarRocks native features to protect our clusters. We have query timeouts based on the expected latency. We can block risky query patterns so that we don't have unexpectedly heavy queries on the cluster. And then finally, we can prevent noisy neighbors on our multi-tenant clusters. One StarRocks feature that we're using is resource groups. That is a feature that will allow us to limit the amount of resources that individual tenants or use cases are using on our clusters. And then the final thing that we do for noisy neighbors is multiple data warehouses. This is the feature that we have now learned is going to be moved to open source. And this allows for full, complete resource isolation to make sure that there are no collisions between use cases. The last thing that I want to talk about is some best practices that we've learned while provisioning multiple different use cases across Intuit for StarRocks. I've tried to categorize these into ingestion and query acceleration. So first, with high throughput use cases, there's the ingestion itself, and we need to make sure that we have assigned sufficient resources within the StarRocks cluster to write all of the data at the required throughput. So for those, we are using number of tablet writer threads and transaction public version worker counts. And then finally, for query acceleration, there are many different avenues that we use to ensure the queries are meeting our expected SLAs. The first that we use is to enable the compaction to fill the data cache. This allows queries to use the data caches on the compute nodes instead of needing to retrieve continuously the data from S3. The next thing is about compaction. Especially with high throughput use cases, we will need to make sure that we are compacting the data at the same rate. Otherwise, scan time will cause the query latency to drop below our expected SLAs. And the final thing that we've done is to enable parallel tablet scans. This is especially useful when you have tablets that may range wildly in size based on cyclical patterns. This allows individual tablets to be split apart by multiple threads, and this can enhance query latency by a very large margin. And finally, I want to conclude with our roadmap. We're extremely excited and proud of all of the features that we've built into our platform using StarRocks so far, but we also have big plans for the future. The first is a read replica in an active-passive dynamic, and this will allow us to have a secondary cluster with all of the same data for multiple different use cases. This can empower exploration of all of the same data that for our production use cases without posing any risk to the primary production cluster. Corollary to that, we also plan to use the external catalog features that StarRocks provides to connect to our data lake directly. We've talked about real-time use cases, but we also want to combine the real-time data with the richness of our data lake, and in using the external catalog feature will allow us to do that. And then finally, we have multi-table transactions. We've talked a lot about in these keynotes about how multiple tables and joining multiple data streams is critical for many use cases and a powerful feature of StarRocks. This will soon be extended to multi-table writes as well, so that we can write data to multiple different tables without needing to worry about inconsistencies across the different tables. Thank you so much for tuning in. It's been an honor to present to all of you. And with that, I will pass it back to Paul so we can continue on with the StarRocks Summit.